Number 3, we're asked to sketch one cycle of each of these graphs that are listed here, or graphs of each of these functions listed here. We are asked to label them, meaning we kind of want to show where they, the important points on the x-axis. So for sine, we know that we kind of pick out some information. For example, the amplitude is 2 because of that 2. The period is changing. It is 2 pi divided by this 3. And there will be a vertical shift down 1 unit. So down 1. And then we'll figure out the horizontal shift because the way we do that is we know that normally we'd see a sketch of sine on the interval 0 to 2 pi, but we modified it. So we're going to figure this out by setting our argument in the interval 0 to 2 pi. And this will tell me an interval where I'll see a single sketch, a one cycle sketch. So I'll add pi to all 3 sides. And I took my 3 out already. And then I'll divide by 3. And so the interval where I'll see a sketch is pi over 3 less than equal x less than pi. And so I'll set this up. I want to go from pi over 3 to pi, so sort of keep it reasonable. So there would be pi over 3, 2 pi over 3, and 3 pi over 3. So there's my start and end. But now I need to get my quadrants in here. Remember, I break it in half and break each of these in half. And so I'll see the sketch of sine on that interval. And I can already sketch it. It's just a matter of getting everything labeled right. And so what I need to do now is find my quadrant lengths. It's quadrant length. And that's going to come from taking the period and dividing it by 4. So take 2 pi over 3 and divide that by 4, multiply by a fourth. And if you do that, you can get 2 cancel, and so you'll end up with a pi. There'll be 2 times 3, this will be pi over 6. We can keep it with the pi over 3 if we like, kind of make it easier to work with, saying it's 2 pi over, sorry, I guess I need to change that. Leave that. I need to do this one. So pi over 3, I'll change it to 6 being 2 pi over 6 here. And that makes it easier because then I just go by pi over 6. So I have 2 pi over 6. Then this one is 3 pi over 6. This is 4 pi over 6, which you can write in a different way, but I'll leave it like that. And this is 5 pi over 6, and I know I've done it right because this is 6 pi over 6. And then sine, the graph, remember, we'll start out here on my first tick mark, and then sine, since it's not, we don't have a negative in front of anything, it goes up, and then it'll come back, hit its low point here, and come back. So here's a sketch of the graph. The only other thing I need to label is to ensure that everybody knows this is incorporating the amplitude of 2 by labeling the y-axis as well. So there's the graph. That's a 1 period sketch, and now you could easily draw a second period by just keep going. You could keep going by pi over 6. Well, next one is done similarly. It's just now I'm doing secant, which means I'll first draw the graph of cosine. So I'm going to actually consider 1/2 cosine 2x minus pi over 2. And I'll do the same as I did above. The amplitude I can see is 1/2. The period is 2 pi over 2 because of that 2, which is pi. And there's no shift, no vertical shift, but there will be a horizontal shift that we'll figure out by setting the argument of 2x minus pi over 2 on the interval. We'll solve the inequality for that being greater than 0 and less than or equal to pi. So I'll first add pi over 2 to all 3 sides. Well, this is 4 pi over 2, so when I add pi over 2, I'll get 5 pi over 2. And then when I divide by 2, I'm going to get pi over 4 less than equal x less than equal 5 pi over 4. So I can start my graph. I'm going to draw the graph of cosine first on the interval pi over 4. We'll say that's pi over 4, and then I need to go out to 5 pi over 4. So there's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So somewhere about like that. Doesn't have to be perfect, but you don't want it to be too far off or you'll get confused on your graph. So there's my, oops, there are my endpoints for my graph. And now I need to figure out, well, break it up like that. And now I need to find those quadrant lengths. So the quadrant length is going to be pi over 4. So it actually did work out nice. This is just exactly how I counted them. This is then 2 pi over 4. This would be 3 pi over 4, 4 pi over 4, and 5 pi over 4. And so my cosine graph, if that's what I were trying to draw, would start at the high point, and then it would come here, hit its low point, come back like this. And I'm going to dot it in because this isn't our actual graph, but that would be the cosine graph, and it would be here at minus 1/2, positive 1/2, but we actually want the secant graph. And so the secant graph, we need to first draw the asymptotes, which are going to be here and here, and then the secant, remember, is kind of attached to my cosine, so it'd go like that, there, and there. Oops, that's not very well done, but anyway, that's approaching that asymptote from that side. So that would be a one-period sketch of that secant. And then finally, we want the tangent graph, which we don't have to do quite as much. There's not an amplitude, but there is a period change here. Period is normally pi, but we divide it by 2, so this has a period of pi over 2. And then I find my interval as 0 less than equal 2x minus pi. Oh, sorry, we're doing tangent. Let me start over. It's not 0. Tangent, remember, is normally between minus pi over 2 and pi over 2, so I need to figure out where that new interval is going to be. So 2x minus pi less than equal pi over 2. So that's normally where we sketch tangent. I'll add pi to all three sides. Well, this is going to give me positive pi over 2 here. And on this side, I'm going to be adding pi, which is 2 pi over 2. So this is going to be 3 pi over 2 on that side. And then if I divide through by 2, I get pi over 4 less than equal x less than equal 3 pi over 4. And so now I can start to sketch. So here's pi over 4. And this would be 2 pi over 4. Let's make it a little longer. Right there, 3 pi over 4 would be somewhere like that. Now, with tangent, these are just actually where the intercepts come, and these should be strictly greater than, less than, anyway, but just giving me the interval. So, because tangent's not actually defined on these endpoints, that's actually where the asymptotes occur. So you'll have an asymptote here, an asymptote here, and then you sketch the tangent graph. Because remember, tangent crosses there and is situated this way.